Good morning and good afternoon to all. Thanks for joining the session. I think you have been gone through interesting topics so for the day. So we're going to cover the topic for productionizing ML model using MLflow model serving feature, which has been newly introduced in the MLflow, maybe close to a year now. This is mainly for people who comes from the ML engineer background. Even some data scientists always facing a challenge. So building a model is a one set of activity where we get into a lot of other challenges like getting a parameter, tuning a parameter, means engineering your features and find which is the right one to use, and hyperparameter tuning and choosing the right model and building your model and do the validation, cross-fault validation. So there are many steps involved building a model. So after you spend enough time to build your model, and when you want to serve to end users, that's a key, because if you the way how you're going to serve your model, that's important, because that's what the people are going to consume and they get the experience, right? When you want to expose your model through web APIs, especially for the real-time consumption, it's always a challenge, because you have to create your REST API for your parameter being passed with the security enabled, and the user has to consume. And moreover, whenever you change your model, so you might use as a Keras and you want to change it to PyTorch, or you want to change it to TensorFlow. So there are quite a bit of libraries going to change, and how you're going to keep intact on your end user experience. That's a always challenge, right? So that's where Databricks MLflow come into picture, the new feature. So which are we going to cover in the session? Myself as Nagaraj, I'm helping building large enterprise-wide distributed system. I've been in the industry for close to 17 years now. I'm part of a architecture engineering team and helping deliver future enterprise analytics systems for large and medium scale industries across different domains.
Thank you, Naga. Hi, this is Nitin Raj, Soundara Rajan, working as a technical consultant and focusing on the advanced analytics, data engineering, cloud scale analytics, and data science, working primarily on the data and the AI practice. So today we are going to, so this is the agenda what we are going to cover today. So first we are going to see on MLflow, and then on the MLflow serving, managed served versions, monitor served models, customized serving clusters, and then finally covering with the Q&A with a demo. So MLflow. So MLflow is an open source platform for the machine learning lifecycle. And MLflow is built on open interface philosophy, defining several key abstractions that allow existing infrastructures and machine learning algorithm to be integrated with the system easily, meaning that if you are a data scientist who wants to leverage the ML model, MLflow, and you are using the particular framework that's currently unsupported, the open interface design makes it extremely easy to integrate that framework and start working with the platform. Effectively, this means that MLflow is designed in principle to work with any machine learning library, any language. Further, MLflow facilitates reproducibility, meaning the same training or production machine learning code is designed to execute the same results regardless of the environment, whether in the cloud or in the local machine or in a notebook. Finally, MLflow is designed with a scalability in mind, meaning it's just useful for the small team of a data scientist, and as it's for a large organization consists of potentially thousands of machine learning practitioners. The MLflow components. So I'm going to walk through the MLflow 4 components: tracking, projects, model, and then the registry. So tracking is a centralized repository for metadata about training session within the organization. Projects is a reproducible, self-contained packaging format from the model training code, and showing about the training code run the same way regardless of the execution environment. MLflow model is a general purpose model format enabling any model produced with MLflow to be deployed to a variety of production environment. And MLflow registry helps to solve 3 critical problems in the production machine learning applications. It prevents from deploying the bad models by introducing the model administration and review. It integrates with the MLflow tracking to provide the complete picture of every model within your organization, including source code, parameters, and metrics. It also provides centralized activity logs, recording entire collaborative process from model development to deployment, complete model description and comments.
MLflow architecture, a high-level overview. Try to picture it in a diagram. If you look at it, the main core components. So MLflow framework fits end-to-end life cycle. If you look at it, so one is preparation of data, where we use as a data source and do some kind of a cleansing, formatting, where we use Spark, Delta Lake. Then we do building a model, where we're going to use ML runtime or any other machine learning libraries on different environments to build our model. We can use many features, so build our respective model, which gives a better results. So once we have the model, then come into picture like a deployment monitor, because scoring is a key part. So that's where the deployment monitor come into picture. So how are you going to enable your model to serve for the end user? So there are two options. One is an online serving, other one is a batch mode, batch or the stream mode. So batch or the stream also runs in the from system side. So that's pretty much we can handle it through the code side. When coming to the online service, so that's where the critical, because we have to expose them as a service, web API. So the downstream application, they can consume and access it. So in this session, we'll get deep dive into the MLflow framework, which recently they launched model serving feature, which covers these three parts. So that's what we're going to cover in this slide. Um, so let's say what is MLflow model serving? So it exposes a REST API. Whenever you build a model, whenever you register a model in the project tracking, uh, when you enable for the serving, it automatically creates a REST API by setting up the cluster behind the scene. Um, you can configure the way how you want to do that. So at the end, without any intervenes like any developer or effort, so it automatically build its own cluster and deploy your model with respective environment, create your REST API. So using the REST API, which you can share it to the users to access it, to pass the value and get the result. Right now, if you look at it, this has been released recently. So there are some limitations being there. Currently, it support up to 50 query per second, like a 15 queries per second, and with a 99.5% availability. So what Databricks recommended is it try to use it for the light load purpose and for testing your model. Testing your serving purpose. So those kind of options you can use pretty much for the model serving. If anything on the business critical, let's wait for some more time. Once the MLflow serving is get well matured, yeah, it will be enabled for the business critical applications too. If you look at it, how this works, so we have a different set of model. So if you look at it, currently MLflow supports TensorFlow, XGBoost, Keras, Scikit-learn, Spark MLlib, Onyx, H2O, and few other models as well. So using those models, you can try build your model. So that's one of the component within the MLflow, which will register like a different flavors. You can register within the MLflow model. So once you have the model, then you can enable the tracking. So tracking is nothing but whenever you run your experiment, right? So you have pass certain parameter. So you have certain data set and you have seen the results, how it comes through, right? So because whenever we want to do the reproducibility, so these are the important factors, because mostly what happened, we can't go back and see how exactly the model been came through, right? So we always have only the model, we not have the history how the model been came through, right? So the tracking servers are one of the really good benefit which capture in everything. So you can add the metric, you can add the artifact, so you can add custom artifact as well. So that's where the tracking server come into picture. The final one is the model registry. So this is one of the important, especially for the release management, because you have the model and you want to do it in a different stages, like a stage production. So even the production, you can do the A/B testing as well. So you can have the two variant, and you can share it to the users, and then you can swap which one is a more active. Then you can enable it for the production. So you can customize it the stages in the model registry. So it's quite easy to handle it. You can through REST API, you can use a Python code, or you can use a UI. You can enable that too. Once the model been available in the model registry, so how are you going to expose to the end user to consume, especially for the real-time use case, right? So that's where models have come into picture. So typically there are open source and also there are some paid libraries like a Seldom Core and KF Serving. So there are quite a bit of tools available. So those are extensively optimized for the model serving, for the scoring servers, they call it as. If you want to do like a simple for your testing without much effort, then I would recommend try for the model serving, which is a more efficient. Comes with the same your Databricks environment, whether you use AWS, GCP, or Azure. It comes with a built-in interface where you can just enable few clicks. You can set up your own cluster for your model to deploy and it run. Typically, it takes all the environment. So let's say staging, production, archive, except the archive, whatever the environment you have, like a A/B testing and then production. So it takes all the four environment and make it live with the URL. So the URL parameters with the production. So even whenever the version got changed, the URL remained the same. So the user who are going to consume it could seamlessly get the same experience. So that's a good part going for the model serving future. I'm trying to depict in a single diagram, like whatever the model we're going to build, which is different flavors of model. So you might use as a different model like a Keras, you might use as a PyTorch, you might use as a Coffee too. So whatever the model you're trying to build, and then you deploy into model registry. So seamlessly you can swap the model different versions and deploy into the model registry, and then you can move across stages like a staging to A or B, and then once you decided which one is best fit for production, you can move the code A or B into production. Automatically, the version, the model server will update your version and expose the REST API. So the REST API remain the same. So users never see any differences at all. So they, as soon as it's been moved into production, the model serving update the model begin the scene, and user whenever send the request, it get the new model outcome. So that's a model serving. So probably it's a good time for us just get into the demo and see how it works in the real world scenario. In this demo, I'm going to walk you through the MLflow serving feature. For doing that, I'm using Iris classifier, which is a well-known example, which has a three different set of flavors, and how we're going to classify into three based on the sepal and petal length and width parameters. Here I'm using sklearn framework, and we uses a one is I'm using the decision tree classifier, other one is a KNN classifier, and see from whenever I do the improvement in the model and how the impact in the end user experience. So that's what I'm going to explain from the ML serving perspective. So let me start with the decision tree. So if you look at the code, I'm just using the sklearn. I'm just importing the decision tree classifier. And this is my data. So I just have some sample data. I just feed into my notebook itself. And then so I have the values. So based on the values, first set of values are refers as a setosa. Second, the middle set of values are vesicolor, and the last one is a vaginica. So these are three set of records I've been created, and I try to train my model. So before that, I just look at how the data being split. So if you look at it, the red color setosa, and the gray color is a Veronica. So you can see how the different data are split across, right? So I'm just using the MLflow to start run to capture, because we're going to use the MLflow framework, right? So MLflow has a project tracking. It tracks the complete version that runs, so we can see how it performs. And then there's a new feature called model serving. So that's where you're going to see. So I'm going to run this code all. So typically, once MLflow capture this, then it's going to register the model. So once the model is registered, so I'm registering under iris model. So once the model is registered, I'm moving the model to production stage. Yeah. So now the code has been completed successfully. So I'm going to show the model screen. I'm just going to refresh the model screen now. So here you're going to see there is a new model called iris model, which I just run the model. Yes, so you can see here the version 1, which I ran the code. That is the latest version and push to production. So I'm just going to the iris model, and as usual, so whatever the parameter I track, so everything will be there. This is just a project tracking. That's one of the feature, and you can see there's a new feature called serving. So this is the easiest way you can enable. Means you package your model for the user to consume through the REST API, especially for the online serving mode. So this is one of the nice feature, I could say. So let's say if I enable it, you can see it automatically set up the cluster, and then it exposes the REST API for user to consume it without any need of development effort. So that's the really good thing. And it also going to capture the events, like what are the events happen in the model. So those also will be captured. And you have a URL. So this is your REST API URL, and if you want to invoke through a browser, just you want to test it, you can test it from here, or you can use the curl or python. So thing is, you need to have the Databricks token. This is for the security, so it's a better token you usually generate from your Databricks. You can create your own token, set your expiry date, and get your token and assign the token here. So that's for authorizing the request to get the data from the model. And you have to pass your URL. So either you can use one or you can use production. So my recommendation is always used to use production, because irrespective of the versions you deploy into your tracking server, if you say production, what are the version available in the production, it always pick the latest version in the production. So that way, from the end user perspective, they don't need to change any code at all. So all they need to do is just call this REST API. Behind the scene, it automatically find the version available in the production. So it will make a respective model and send the request and get the result back to end users. And you can see now my cluster is ready. Now what MLflow does here is he try to package my model and deploy my model into the cluster and create the web APIs for my cluster, which assigned to this one. So it has a input and output. So input is the parameter which I'm going to pass, like a sepal and petal length and width, and output is my value, whether what kind of iris flower it is. Okay. um, Now you can see both are turned to green. It means now my model is readily available in the cluster for consumption. So anyone can raise a web API request and get the results. So let me pick the sample data, which I can show you. um, okay, so here you can see I have two set of data. um, so first I have value 1, and then I have second row. So I'm going to pass two set of records and see how the value it get predict from the version 1, which I use decision tree. So I just pass some random values for the sepal and petal length and width. I just click the send request, and you can see both are comes as a vertigo iris flowers. um, Behind the scene means if you scroll down and you could look at the logs, what are things happen in the behind the scene, how the model being deployed. So all the events logs, everything being captured. uh, and the version wise, is there any version being deployed, any change happens, let's say if new version being deployed, so those will be captured here. So let's say if a new version being deployed with a more accuracy, yeah, you can get that as well. So now you can see these values are more seems to be like a vertigo. So that's what this model predicted. If you look at the model, if you go here, and you can see the accuracy is a zero 0.6. So that's the accuracy for this decision tree model. Um, so this is a quite easy. So I can easily enable. I build the model. I can easily enable it for the user to consume without much of work from a ML engineer perspective as well as from a data science perspective. It makes more easier for me to do that. Let's say if you want to change your cluster size, so here you have options. So there is a cluster setting. Here you can see there are different set of clusters available. So you can set what kind of a VM you need, like a cluster you need, compute power, whether memory optimized or compute optimized, storage optimized, depends on your need. You can set the respective cluster, and you can save the particular cluster type. So whenever you want to serve your model, automatically the cluster it pick the whatever the setting you made it in the screen. So that's a quite easy one, I could say. So anyone can easily set up the cluster, and then it, yeah, pretty much runs well. So that's about the MLflow serving feature. So now what I'm going to do is my colleague going to run with the next version and see how the transition happen. So over to you.
Now we are going to improve the accuracy of the model, which was used earlier with the classic decision tree algorithm, which has given us the 60% of the accuracy. Now we are going to improve the accuracy of the model by using the KNN algorithm. So in this particular notebook, we have used the k-neighbor classifier from the sklearn library, and we have used the same sort of code and sample data to train the model as well. So now we are going to run this particular notebook and see the improvement in the accuracy. So I'm just clicking on the run all. We can see that that there is an improvement of 94% in the accuracy of the model as we are using the KNN algorithm. The notebook has got completed, and now let us go into the model and see the serving. So we can see that in the iris model, the version 2 has got deployed, which we run recently now. Just now we have run it, and we can see that version 2 is now in production. So I'm going into the serving, and so within the serving, we can see that version 2 is still pending. So it will take another couple of minutes to move into the ready state. Yeah, now we can see that the version 2 has got moved into the ready state. Now we are good to go in our testing of giving the sample input in the request box so that we can see what is the response. So let us first give the sample input for the version 1, and let me click on the send request. What we can see is that so both are Virginica in the version 1 for the given input. And then now let me use the same input in the version 2 that we have deployed recently with the KNN model. And I'm using the same set of input in the request box, and then I'm just giving the send request. Here we can see that 1,2, which is nothing but vesicle and Virginica. So this is because of the improvement in the model to 94%. So that is the key point over here, what we are seeing here. And so whenever, even though we have run the two different models, there is no change in the consumption link in the request URL. The request URL will be always in the production. There is no change in the versions or model names that we need to specifically give in the request URL. So we are going to always point towards the production URL, which will give us or redirect to the recent versions that is pushed to production right now. So, and we can in the log section we can see that the conda activate model 2. So the model 2 is posted to the production.
As you have seen in the demo, so we are going to see the managed served versions. So All active non-archived model versions are deployed, and you can query them using the URIs. Azure Databricks automatically deploy the new model versions when they are registered and automatically removes the old versions when they are archived. Managing the model access rights. Model access rights are inherited from the model registry. Enabling or disabling the serving feature requires manage permissions on the registered model. Anyone with their read rights can score any of the deployed versions. Scoring the deployed model versions. To score a deployed model, you can use the UI or send a REST API request to the model URI. So scoring via UI. So this is the easiest and fastest way to test the model. You can insert the model input data in the JSON format, and then you can send the request to the service. If the model has been logged with an input example, so then we can able to see the corresponding output. And scoring via the REST API request. You can send a scoring request through the REST API using standard Databricks authentication. Moving on to the monitor served models. The serving page displays the status indicator for the serving cluster as well as the individual model versions. In addition, you can use the following to obtain the further informations. To inspect the state of the serving cluster, use the model event tabs, which displays a list of all the serving events for this model. To inspect the state of a single model version, use the logs or version event tabs on the model version tab. Customize serving cluster. To customize the serving cluster, use the cluster setting tabs in the serving tab. To modify the memory size and the number of cores of a serving cluster, use the instance type dropdown when to select the desired cluster configurations. You can add the tags for the registered models to refer later in the other places. And then you can also edit or delete the existing tags. So that's all from the model serving perspective. And please raise your questions, and so that we will answer your questions.